Let us start atomic structure. In the atomic structure, we will discuss charges of subatomic particles. We will discuss charges of subatomic particles. Charges of subatomic particles we will discuss. What are the subatomic particles? Electrons, protons, neutrons. Now we will see charge of electron. We will see charge of electron is a minus 1.602 into 10 to the power of minus 19 coulomb. Minus 19 coulomb in a SI system. In a SI system, charge of electron is minus 1.602 into 10 power minus 19 coulomb in SI system. In CGS system, minus 4.8 into 10 to the power of minus 10 ESU. This ESU is called electrostatic unit. This ESU is called electrostatic unit. Next, we will see relative charge of electron. Relative charge of electron. Relative charge of electron is said as minus 1. This minus indicates electron is negatively charged particle. So relative charge of electron is how much? Minus 1. Relative charge of electron is minus 1. Sorry. Next we will see charge of proton. We'll see charge of proton. Charge of proton is equal to 1.602 into 10 to the power of minus 19 coulomb in SI system. In SI system, 1.602 into 10 power minus 19 coulomb. Next, charge of proton in CGS system. Charge of proton in CGS system, 4.8 into 10 to the power of minus 10 ESU. ESU is called electrostatic unit. Next, we will see relative charge of proton. Relative charge of proton. Relative charge of proton is plus 1. Relative charge of proton is plus 1. Next, we will see charge of neutron. Charge of neutron is equal to 0. Charge of neutron is equal to 0. Sorry. Now, let us compare charge of electron and the charge of proton. Charge of electron value and the charge of proton value both remain same. Charge of electron, charge of proton remain same in SI system. Charge of electron in CGS system, charge of proton in CGS system remain same. Relative charge of electron is minus 1. Relative charge of proton is plus 1. So, proton is positively charged particle, electron is negatively charged particle. So, relative charge of electron is given minus 1. Relative charge of proton is given plus 1. Charge of neutron is 0. Charge of neutron is 0. Sir. Now, we will take hydrogen atom. We will take hydrogen atom. Its atomic number is 1. We will take hydrogen atom. Its atomic number is 1. Its mass number is 1. Its mass number is 1. This atomic number is equal to number of electrons or number of protons of an atom. So atomic number is equal to number of electrons or number of protons of an atom. Mass number is equal to number of protons. Mass number is equal to number of protons plus number of neutrons. Number of protons plus number of neutrons. It is mass number. So see that atomic number equal to number of electrons or number of protons of an atom. mass number is equal to number of protons plus number of neutrons. Now you say, in the hydrogen atom, how many electrons present? Hydrogen atom contains how many electrons? How many electrons does hydrogen atom have? How many protons do hydrogen atom possess? How many neutrons? How many neutrons hydrogen atom is having? That you say. So hydrogen atom, if we take, it is having how many electrons? It is having how many protons? It is having how many neutrons? You see. Now here hydrogen atom we have written. Left side bottom we have written atomic number. Atomic number symbol is Z. Atomic number of hydrogen atom is nothing but number of electrons or number of protons. So number of protons or number of electrons is called atomic number. Right side of this symbol, right side of this symbol top, right side of this symbol top, we have written mass number. Right side of this symbol top, we have written mass number. Mass number is equal to number of protons plus number of neutrons. Now you say, what is the number of electrons of hydrogen atom? Hydrogen atom contains how many electrons? So number of electrons is equal to atomic number. Atomic number is equal to 1. So hydrogen atom is having 1 electron. 1 electron for which relative charge is -1. Sorry. Atomic number is also called the number of protons. Number of protons is nothing but atomic number. Atomic number of hydrogen is 1. So hydrogen contains 1 proton. Hydrogen contains 1 proton. For 1 proton, relative charge is +1. Next. Now, number of protons. Number of protons is 1. That we will substitute here. Number of protons is 1. Let us substitute number of protons here. That is 1. Mass number let us substitute. That is 1. Mass number is 1. Number of protons is 1. Therefore, number of neutrons of hydrogen atom is 0. Number of neutrons of hydrogen atom is 0. Now we will see net charge. We will see here for electrons -1 charge, for protons +1 charge, net charge is 0. Therefore, atom is neutral. Atom is neutral. For hydrogen atom, net charge is 0. Therefore, we can say atom is neutral. Net charge of an atom is 0. Sir, let us remove 1 electron from hydrogen atom. Let us remove 1 electron from hydrogen atom. What is the resultant that we will see? Resultant we will see. What is the charge for this that we will see? Now, in this resultant number of electrons we will see. Already it is having 1 electron. Here 1 electron is there. That electron is removed. Therefore, now number of electrons 0. Regarding protons, no change. So protons as it is present, that is 1. 1 proton is present. 1 proton means +1. Neutrons 0. Neutrons 0 present. Neutrons not present. So total charge is +1. So this total charge we will give here. Total charge we will give here. So if atom loses 1 electron, it gets +1 charge. If atom loses 1 electron, it gets a +1 charge. Hydrogen atom loses 1 electron, so it gets a positive charge. It is getting +1 charge. +1 charge we are saying. Okay. Now, if it gains 1 electron, if it is losing 1 electron like this, now we will take, in another way we will take, it is gaining 1 electron. Hydrogen atom is gaining 1 electron. Gain an electron. Hydrogen atom is gaining an electron. Now what will happen, that we'll see. Now regarding electrons, we'll see. Already this hydrogen atom is having 1 electron. This hydrogen atom is gaining 1 electron. Therefore, number of electrons becomes 2 electrons. 2 electrons means -2. For 1 electron, relative charge is -1. For 2 electrons, relative charge is -2. Regarding protons, here 1 proton is there. Regarding protons, no change. So protons number is 1. For relative charge of proton is +1. Regarding neutrons, neutrons no change. Neutrons already 0 present. Okay. Now we will see net charge. We will see net charge is -1. Net charge is -1. Now we will write this symbol. Hydrogen symbol is H. Now net charge is minus 1, that minus 1 will write. So if an atom gains an electron, if an atom gains an electron, it will get minus 1 charge. Gaining of an electron, getting minus 1 charge. Now, gain of electron is called reduction. Gain of electron, we will call it as reduction. Gain of electron is called reduction. Loss of electron is called oxidation. Loss of electron is called oxidation. Loss of electron, we will call it as oxidation. Now, hydrogen will show H plus in which place? In the HCl, if you see, in the HCl, hydrogen is having plus 1 charge, Cl is having minus 1 charge. Hydrogen can show minus 1, in which case means sodium hydride. We are taking NaH. NaH is called a sodium hydride. Sodium hydride. Hydride spelling is Hydride, hydride. In the sodium hydride, sodium is having plus 1 charge, hydrogen is having minus 1 charge. Like this possible. So that if an atom loses one electron, if an atom loses one electron, it will get plus 1 charge. Loss of electron is called oxidation. If an atom gains an electron, if an atom gains an electron, it will gain minus 1 charge. It will gain minus 1 charge. Gain of electron is called reduction. Gain of electron is called reduction. Now, this is a negative ion. It is a negative ion. It is positive ion. It is atom. Atom is having net charge 0. So, atom is neutral. Atom we can say, neutral we can say. Now we will take sodium atom. We will take a suppose we are taking a sodium atom. We are taking for sodium atomic number is 11. For sodium atomic number is 11. Mass number is 23. Mass number is 23. Sodium we have taken. Sodium Latin name is, we are taking sodium. For sodium Latin name is natrium. Natrium. For natrium, first two letters Na, that is Na is the symbol for sodium. For sodium, symbol is Na. For sodium, atomic number is 11, mass number is 23. Now say, sodium is having how many electrons in it? How many electrons present in sodium? Now you say number of electrons of sodium. Number of electrons of sodium you say. How many electrons does sodium is having? How many electrons sodium is having? What do you say? Sodium is having how many electrons? Sodium is having how many electrons? Sorry. Now you see number of electrons. Number of electrons is called atomic number. Atomic number is equal to number of electrons or number of protons of an atom. Okay. Atomic number is equal to number of electrons or number of protons of an atom. Atomic number is equal to number of electrons or number of protons of an atom. So atom is having how many electrons means that is equal to atomic number. Therefore, now you say what is the number of electrons of sodium atom? What is the number of electrons of sodium atom? Do you say how much value do you say? Number of electrons. Sodium atom is having how many electrons? Okay. Sodium atom is having 11 electrons. 11 electrons it is having. So 11 electrons, for 1 electron relative charge is minus 1. So for 11 electrons relative charge is minus 11. And atomic number is also called number of protons. So sodium atom is having how many protons? Protons is equal to 11 protons. 11 protons. Relative charge of proton is plus 1. So 11 protons means plus 11. Then we will see neutrons. We will see neutrons in the sense this mass number minus atomic number is called neutrons. Mass number minus atomic number is called neutrons. So this 23 minus 11, that is 12 neutrons. Neutrons charge is 0. Neutron charge is 0. So net charge is 0. So for sodium atom, net charge is 0. For sodium atom, net charge is 0. So sodium atom is a neutral. Sodium atom is neutral. Okay. Now sodium atom loses one electron. Now we will take sodium atom is losing one electron. Sodium atom is losing one electron. So what is the resultant that we will see? Now we will see the electrons. Already it is having 11 electrons. Now it is losing one electron. Therefore number of electrons becomes 10. 10 electrons. For each electron relative charge is minus 1. For 10 electrons charge is minus 10. Regarding number of protons no change. Regarding number of protons no change. That is 11 protons. Proton relative charge is plus 1. So for 11 protons, total charge is plus 11. Regarding neutrons, no change. Regarding neutrons, no change. That is 12 neutrons. For neutrons, charge is 0. Therefore, net charge is plus 1. Net charge is plus 1. Therefore, sodium is getting a plus 1 charge. Sodium is getting plus 1 charge. So, if an atom loses an electron, it will get plus 1 charge. If an atom loses an electron, it will get plus 1 charge. Now we will take magnesium can lose 2 electrons. So what is the charge magnesium will get it? Magnesium can lose 2 electrons. So what charge does it get? Magnesium can get what charge? Magnesium can lose 2 electrons in the chemical reaction. Magnesium can lose 2 electrons in the chemical reaction. That indicates magnesium can get what charge? What is the charge magnesium can get it? Magnesium is able to lose 2 electrons in the chemical reaction. So magnesium will get a plus 2 charge. Aluminum can lose 3 electrons. Aluminum can lose 3 electrons in the chemical reaction. So aluminum will get a what charge? What charge aluminum will get it? Aluminum will get a plus 3 charge. Aluminum will get plus 3 charge, not minus 3. It will get plus 3 charge. It will get aluminum can lose 3 electrons, so it will get plus 3 charge. Sulfur can gain 2 electrons. Sulfur can gain 2 electrons. So what charges can sulfur get it? Sulfur can gain 2 electrons. Sulfur can gain 2 electrons. So what charge can it get it? Gaining an electron means gaining negative charge. Therefore it will get a 2 minus charge. Nitrogen is able to gain 3 electrons. Nitrogen is able to gain 3 electrons. So what charge it will get it? Nitrogen is able to gain 3 electrons. So what charge it will get it? It will get minus 3. This nitrogen is having minus 3 is called nitride. Nitrogen is having minus 3 is called nitride. So what is the what is the example for this? We'll see. Now we'll take this magnesium. Magnesium is plus 2. Nitrogen is 3 minus. That will take. Magnesium and nitrogen will take. Magnesium is having 2 plus charge. Here magnesium is having 2 plus charge. Here nitrogen is having 3 minus charge. Nitrogen is having 3 minus charge. We will take these two. Let us cross multiply. We will get Mg3N2. What is the name of this compound? This compound is called magnesium nitride. Magnesium nitride. Magnesium nitride we can say. Magnesium nitride. Cell. Next, we'll see about mass of subatomic particles. Mass of subatomic particles, let us see. Mass of subatomic particles, let us see. We will discuss about mass of subatomic particles. Mass of subatomic particles we will discuss. Mass of subatomic particles. Now mass of electron. Mass of electron is 9.1 into 10 to the power of minus 31 kilogram in SI system. Mass of electron is 9.1 into 10 to the power of minus 31 kilogram in SI system. In CGS system, 9.1 into 10 to the power of minus 28 grams in CGS system. 9.1 into 10 power minus 28 gram in CGS system. It is a mass of electron. Next we will see mass of proton. We'll see. Mass of proton. Mass of proton is 1.672 into 10 to the power of minus 27 kilogram mass of proton. Mass of proton we have given. So one student asking that what is the formula for a magnesium nitride? Magnesium nitride. What is the formula of magnesium nitride? One student is asking. So that we will repeat. Now you are asking a magnesium nitride. You are asking magnesium nitride formula. Sorry. So we will see regarding magnesium nitride. You are asking magnesium nitride formula. Magnesium can lose 2 electrons, therefore it can show +2 charge. Magnesium can lose 2 electrons, therefore it can show +2 charge. Nitrogen can gain 3 electrons, therefore it can show 3 minus charge. Nitrogen can gain 3 electrons, therefore it shows 3 minus charge. Next, in order to get formula, let us cross multiply. Like this, we will cross multiply. This 3 comes here, this 2, now cross multiply, 2 goes to this place. So, we will write this Mg, we will write, this Mg we will write, this 3 comes to magnesium, this nitrogen will write, this 2 goes to this place. Okay. Why to cross multiply this one? Why to cross multiply this one? Here magnesium 3 times present. Magnesium 3 times present. Its charge is +2. Its charge is +2. Therefore, total positive charge is +6. Nitrogen 2 times present. Its charge, nitrogen charge is -3. Nitrogen charge is -3. Let us multiply, we will get -6. So total charge positive, total negative charge are equal. Therefore, this compound is neutral. The compound is neutral. Net charge is 0. Compound net charge is 0. So magnesium nitride formula is Mg3N2. Likewise, calcium phosphide. We'll see calcium phosphide. Calcium phosphide. Calcium symbol Ca. First 2 letters is the calcium symbol. First 2 letters. Calcium is able to lose 2 electrons, so it gets a net charge 2 plus. Phosphorus, first letter P. Phosphorus is able to gain 3 electrons, therefore it shows 3 minus charge. P3 minus is called phosphide. P3 minus is called phosphide. Now in order to get the formula, let us cross multiply. Cross multiply like this. Next, this goes to this place. So we will get the formula calcium. This 3 goes to this place. You are correct. Ca3P2. You are correct. Ca3P2. Calcium phosphide. Calcium phosphide, we can get it. So now we will go for a mass of subatomic particles. We will take mass of subatomic particles. Mass of electron is so and so. Mass of proton is this much. Then mass of neutron. Mass of neutron we'll see. Mass of neutron is 1.675 into 10 to the power of minus 27 kilogram. 1.675 into 10 to the power of minus 27 kilogram. Set. It is mass of neutron. Now let us compare mass of proton and mass of electron. Let us compare. Mass of proton and mass of electron we will compare. So mass of proton and mass of electron will compare. Which is having higher mass, you see. Mass of proton is 10 power minus 27 kilogram. Mass of electron is 10 power minus 31 kilogram. So mass of proton is 10 power minus 27 kilogram. Mass of proton is 10 power minus 27 kilogram. Mass of electron is 10 power minus 31 kilogram. So mass of proton is greater than mass of electron, we can say. Mass of proton is greater than mass of electron, we can say. So, which is having higher mass? Proton is having higher mass. How many times that of electron? How many times that of electron means so and so times. So, mass of proton is 1836 times that of mass of electron. Mass of proton is equal to 1836 into mass of electron. So, mass of proton is 1836 times that of mass of electron, we can say. So, mass of proton is higher. Okay. So, we have discussed charge, we have discussed, and mass we have discussed. Charge and mass we have discussed. Next, we will go to the term that is called charge by mass. Charge by mass ratio. In which experiment gives charge by mass ratio? Charge by mass ratio is given by which experiment? That we will see. Now, charge of electron, charge of subatomic particles. Charge of electron is determined from which experiment? Charge of electron is determined by so and so experiment. Mulliken's oil drop experiment. Mulliken's oil drop experiment gives the value of charge of electron. Mulliken's oil drop experiment gives charge of electron. Charge of electron is determined experimentally by Mulliken's oil drop experiment. Now, now we will see charge by mass ratio is from J.J. Thomson experiment. J.J. Thomson experiment. J.J. Thomson conducts experiment. From that experiment, charge by mass ratio is obtained. So, charge is obtained from Mulliken's oil drop experiment. Charge by mass ratio is obtained from J.J. Thomson experiment. Using these two, using charge and this ratio, what can be calculated? Mass can be calculated. That mass of electron is this much. So that charge of electron is determined from Mulliken's oil drop experiment. Charge by mass ratio is determined from J.J. Thomson experiment. Using charge value, charge magnitude, and charge by mass ratio, this magnitude, what we can find? Mass of electron, we can find it. Mass of electron, we can find. So, now, here, using J.J. Thomson experiment, we are getting charge by mass ratio. This charge by mass ratio is also called a specific charge. Charge by mass ratio is also called a specific charge. So specific charge is equal to what? Charge by mass. Charge by mass. Charge by mass is called specific charge. Charge by mass of electron is determined from J.J. Thomson experiment. Now, the ratio charge by mass is called specific charge. Now, shall we say all the matter consists of atoms, shall we say? All the matter consists of electrons and the nucleus, shall we say? Sorry. Now, you say that which particle possess highest specific charge in the universe? Which particle possess highest specific charge in the universe? What do you say? Highest specific charge in the universe is what? Highest specific charge. Sir. Now we are asking that highest specific charge. So this should be highest. This should be highest. It is highest in the sense one possibility this value is this value is highest and this value is least. This is one possibility. Okay. Otherwise, we can take, this is one possibility. Next possibility, we can say mass is least. Mass is least. Mass is least. Regarding charge, regarding charge, what value will be there? Regarding charge, what value will be there in the sense that depends on other factors also. So regarding charge, we will leave this magnitude. We will take mass alone. This mass will be least value. The mass will be least value. Then specific charge will be highest value. Okay, this is one possibility. It is highest if it is least. So, which particle in the universe possesses highest specific charge? Highest specific charge. Sir, particle. Particle means which we have to take. You take particle in the place atoms. You can take in the place of particles. In the place of particles, you can take atom. Otherwise, molecule. Otherwise, molecule. Otherwise, ion. Ion in the sense cation or anion. Okay, cation or anion you can take. Otherwise, subatomic particles you can take. Subatomic particles you can take. Subatomic particles means electrons, protons, neutrons, like this. Anyone you can take. Okay. Now you say any out of this you can consider this specific charge of an atom, or specific charge of molecule, or specific charge of ion, or specific charge of any one of the subatomic particle. Whatever you want, you can consider it. Now we want specific charge should be highest. For which particle specific charge is highest in the universe? Okay, specific charge is highest in the universe is which one? Which one do you say? Sir, so you are saying proton. You are saying proton. You are saying we will check it correct. We will check it electron. We will check it correct or wrong. You are saying proton is the answer. You are saying, sir. Why do you take proton? Oh, sorry. Proton you are considering. Sorry, you are saying many students are saying proton. You are saying proton in the sense with respect to positive charge you have taken. With respect to positive charge, have you considered with respect to positive charge? Sir, you came to an idea proton. Sorry, as per your point of view, we will take proton. We will take another particle, electron also we will take. Let us compare. Now we will write a charge of proton. Charge of proton. This charge we have to substitute now. Charge of proton we will substitute by mass of proton we will substitute. Mass of proton we are substituting. Mass of proton is 1.672 into 10 to the power of minus 27 kilogram. Mass of proton we substituted. Charge of proton will substitute 1.602 into 10 to the power of minus 19 coulomb. Sorry. Charge of proton we substituted 1.602 into 10 power minus 19 coulomb. Mass of proton we substituted 1.67 into 10 power minus 27 kilogram. Sorry. Now we will see regarding electron. Regarding electron, charge of electron will substitute 1.602 into 10 to the power of minus 19 coulomb in SI system. Mass of electron is 9.1 into 10 to the power of minus 31 kilogram. Mass of electron we substituted. Now see, for proton specific charge is coulomb per kilogram. For electron, specific charge is coulomb per kilogram. For electron, specific charge is coulomb per kilogram. For proton, specific charge is coulomb per kilogram. Now let us see the magnitude, specific charge magnitude. Here for proton numerator, for electron numerator remains same. For proton numerator, for electron numerator remains same. There is no difference. Denominator for proton you see, denominator for electron you see. Denominator for proton, denominator for electron. Which is having lower value you see. For electron, denominator is having lower value. For proton, denominator is having higher value. But the numerator is same for proton as well as electron. Okay. Now you say specific charge magnitude is highest for which one? For electron shall we say, or proton shall we say? Here we need not consider a minus sign. Here minus we will write now here minus and plus. This plus indicates it is positively charged particle. That's all. This minus indicates it is negatively charged particle. It does not mean that this value is a negative value. Okay, this minus sign indicates electron is negatively charged particle. The magnitude is not negative. The magnitude is not negative. Similarly, here positive indicates proton is a positively charged particle. That's all. So we need not consider about this sign then. We need not consider about this sign. Okay. Now we will say regarding a proton specific charge and electron specific charge, charge of proton and charge of electron remains same. Numerator same for both. Denominator is high for proton and low for electron. Now you say highest specific charge is for proton or electron. What do you say? Highest specific charge shall we say as proton or shall we say as electron? Now highest specific charge is for electron. So that among the universe, specific charge of electron is highest. Specific charge of electron is highest. So now you are given what are the particles? One is neutron, one is alpha particle, one is electron, and one is proton, and one is proton. You are given these are the particles: neutron, alpha particle, electron, proton. Now we have to compare the specific charge. Let us compare the specific charge of these particles. What is alpha? We will see. In order to understand alpha, let us take helium atom. Helium atom, atomic number 2, mass number 4. So helium atom is having 2 protons, 2 electrons. 4 minus 2 is 2, therefore 2 neutrons. Protons is having plus 1 relative charge, 2 protons, so plus 2. Electron is having relative charge minus 1, so minus 2. It is 0. So net charge is 0. Let us remove 2 electrons from helium atom. So resultant says it is having 2 protons, electrons is 0, neutrons is 2. Net charge is plus 2. So helium is having plus 2 charge. It is called alpha particle. Alpha particle is called a dipositive helium ion. Dipositive helium ion is called alpha particle. Now you say alpha particle possess only